Hello friends, this video on solutions part 30 is brought to you by examfear.com. No more fear from exam. Let's take one example. The question says the vapor pressure of pure water is equal to 23.8 mm Hg. Right? This is, let's suppose, pure water. The vapor pressure is 23.8 mm Hg. 50 gram of urea, let's suppose this is 50 gram of urea, is added in 850 gram of water. This is 850 gram of water. So we have to find the vapor pressure of the solution and also the relative lowering. We know that the moment you add a solute, for example in this case, the vapor pressure will be less. So in this case the vapor pressure will only be because of P2, because P1 is anyway non-volatile. Urea is non-volatile. Correct. So we have to find P2. P2 is what? P2 is nothing but P2 naught into mole fraction of 2, and 2 is what? Water here, and mole fraction of water is what? P2 naught. Mole fraction of the water is nothing but moles of water by moles of water plus moles of urea. Correct? So let's find this moles of water and moles of urea. So what is the moles of water? Moles of water is mass of water, that is 850 gram, by molar mass of water, that is 18 gram per mole. You know that H2O, 2 into 1 plus 16 is 18 gram per mole. You solve this, you get 47.22 mole. Correct. Similarly, molar mass of urea. Molar mass of urea is nothing but mass of urea moles of urea is nothing but mass of urea, that is 50 gram, by molar mass of urea. Molar mass of urea, if you find, is nothing but 60. If you say this is 14 plus 2 hydrogen 2 plus carbon 12, oxygen 16 plus nitrogen again 14, 2 hydrogen 2. You add all these, you get 60 gram per, and that is nothing but 0.83. So let's put in this formula. So with the formula we have drawn was P2 is nothing but P2 naught into mole fraction of water by, moles of water by moles of water plus moles of urea. Let's put the value. P2 naught is what? 23.8 mm of Hg into moles of water is what? 47.22. Correct. Divide by moles of water, that is 47.22, plus moles of urea, that is 0.83. You solve this, you get 23.4. So the new pressure is 23.4, and unit will be what? This is mole, this is mole. It cancel, it will be mm of H. And what is the decrease in pressure? Decrease in pressure is nothing but the old pressure, that is P2 naught, minus new pressure, that is P2, that is nothing but 23.8 minus 23.4 mm of Hg, that is nothing but 0.4 mm of Hg. That is the decrease in pressure. The question says the boiling point of water at 750 mm of Hg is 99.63 degrees Celsius. How much sucrose is to be added to 500 gram of water? This is 500 gram of water, such that it boils at 100 degree Celsius. So there is a change in boiling point, right? Change in boiling point is what? 100 degrees Celsius minus 99.6 degrees Celsius. So let's convert this into Kelvin actually, because we have to find delta T in Kelvin, right? So this becomes 100 plus 273 K minus 99.63 plus 273 K. So this you get 0.37 Kelvin. That is my change in temperature. That is given. So change in boiling point actually, that is. And the formula, the moment we talk about change in boiling point, the only formula we know is delta change in boiling point is nothing but Kb into m. correct? And since we are talking about water, the value of Kb is something we know, the value of Tb is something which we know here. M is what? Molality. So from here I can find the molality of this solution, correct? Molality is nothing but moles of sucrose here, because sucrose is something which I am adding here. Moles of sucrose by mass of water in kg. So mass of water is given. So moles of sucrose I can find. Sucrose, I know the chemical formula, I can find the molar mass of sucrose. So I can easily find the mass of sucrose. And that is something I have to find, right? How much sucrose has to be added. So let's do that. Delta T is equal to Kb into M, right? And M is nothing but molality, that is nothing but moles of sucrose by mass of water in kg. Let's put the values in. Delta Tb is what? 0.37 K. What is the value of Kb? Kb is 52 K kg per mole. It is actually 0.52 K kg per mole. That is the molar elevation constant. We know that this value of Kb from the chart. So this into moles of sucrose is what? Mass of sucrose by molar mass of sucrose. So mass of sucrose is something you have to find. Mass of sucrose by molar mass of sucrose, you find it will be 342 gram per mole into mass of water in kg. Mass of water is 500 gram. That is nothing but 500 by 1000 kg. Correct? I'll show you how the moles of molar mass of sucrose is 342. See, sucrose is what? Sucrose is C12H22O11. So you want to find the molar mass. 12 into, is C11H211. So it's 11 into 12 plus 1 into 22 plus 11 into 16. If you solve, you will get 342 gram per. So you solve this equation, you get mass of sucrose as nothing but, I have 0.37 here, K into 342 gram per mole into 500 kg divided by 0.52 kg per mole into 1000, right? Per mole cancel, kg cancel, and k cancel. Solve this, you get 121.67 gram, and that is my answer. So the mass of sucrose that has to be added is 121.67 gram, so that the boiling point decreased to 99.6 degrees Celsius from 100 degrees Celsius for water. The question says calculate the mass of ascorbic acid to be dissolved in acetic acid to lower its melting point by 15.6 degrees Celsius. This is acetic acid is my solvent here, and in this I am adding this solute. So my red one is my solute generally. So this is my solute, and this is my ascorbic acid or vitamin C, and this is my acetic acid. Correct? So the question says we have 75 gram of acetic acid. This is 75 gram, and we have to find the mass of this ascorbic acid that is to be dissolved in this acetic acid, so that the whole melting point decreases by 1.5 degrees Celsius. So the formula we know is delta TF is nothing but Kf into molality. So the first thing is, let's talk about delta TF. We told that delta TF, or change in the temperature, will always be in Kelvin, but it is in Celsius. What to do? So please note that if it is in Celsius or if it is in Kelvin, it's all same as far as delta T is concerned. I'll tell you why. For example, I have initial temperature as 50 degrees Celsius and final temperature as, let's suppose, 45 degrees Celsius, right? So delta TF is how much? 50 minus 45 is 5 degrees Celsius. If you want to convert this into Kelvin also, this becomes 50 plus 273 Kelvin, minus 45 becomes 45 plus 273 Kelvin. So you solve this gets cancelled and you get 5 Kelvin. So when you talk about change in temperature, delta T, if it is in Celsius or if it is in Kelvin, it's all same. Please note it's only for change, delta T, right? So I can write 1.5 degrees Celsius as nothing but 1.5 Kelvin, right? It's nothing but Kf is given 3.9 kg per mole into M. M is the what? M is molality of the solution. That is nothing but moles of ascorbic acid, right? Moles of ascorbic acid, or I can say vitamin C, divided by mass of my solvent, that is acetic acid, in kg. Correct? So let's put the value now here, or I can say that 1.5, this k cancel by 3.9 kg per mole is nothing but moles of acetic vitamin C. I can say that nothing but mass by molar mass. Mass of vitamin C, which we don't know actually, by molar mass of vitamin C. So molar mass of vitamin C is I can easily find. It will come out to be 176 gram per mole. So I'll write here 176 gram per mole, right? Because moles is nothing but mass by molar mass. You can find 6 into 12, 8 into 1, 6 into 16. You'll add, you'll get 176, right? Divide by mass of acetic acid. Mass of acetic acid is 75 gram. So 75 gram is nothing but 75 by 1000 kg, right? Kg cancel, per mole cancel. So if you solve this, you get mass of vitamin C or acetic acid is nothing but 176 into 1.5 into 75 by 3.9 into 1000, and it will be gram. And you solve this, you get 5.08 gram, and that is nothing but the mass of vitamin C that has to be added in 75 gram of acetic acid to lower its melting point by 1.5 degree Celsius. It's a very straightforward question. We have to find the osmotic pressure in Pascal exerted by a solution prepared by dissolving 1 gram of polymer. Molar mass is given, volume of water is given, temperature is given. Know that osmotic pressure is nothing but N by V RT, and this N is nothing but moles of solute, and T has to be in Kelvin. So T is 37 degrees Celsius, we will convert into Kelvin. So we'll add 273 to it. You get how much? 310 Kelvin. This is something we know. Value of R is constant, we know that. Now what is the value of V? V is what? Volume of water, that is given in milliliter. We can convert into liter. This becomes 0.45 liter. We know this. Moles of solute is what? Mass by molar mass. Mass is given, molar mass is given. So we can just put the values. So moles of solid is nothing but 1 gram by molar mass, that is this. This is gram per mole, into R. Since I have to find Pascal, or sorry, into 1 by V. V is what? 0.45 VL into R. R is something we have to, since it is in Pascal, R is nothing but 8.314 into 10 to the power 3 Pascal liter per Kelvin per mole. Please note the unit of Pascal depends on the unit of vapor pressure you have to find. Since it is Pascal, I have to use this as my R. Into T. T is what? 310 Kelvin. Now we see a lot of things get cancelled. K gets cancelled, right? Liter gets cancelled, correct? Per mole gets cancelled. Gram gets cancelled. Right? If you solve this, you get 30.98 Pascal or almost 31 Pascal. 31 Pascal is the osmotic pressure of this solution. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.